Hello students, welcome again to my channel DNA.on to Education. Today our topic is work and energy. Work and Energy, Physics for International Curriculum by DNA.1 to Education. Okay students, what is work and what is energy? Okay, students, to understand about work and energy, for the first, we have to understand first about conservation of energy. What is conservation of energy? The law of conservation of energy states that energy can neither be created nor destroyed, only converted from one form of energy to another. Once again, energy can neither be created nor destroyed, only converted from one form of energy to another. This means that a system always has the same amount of energy unless it's added from the outside. We call this one conservation of energy, or we call this principle of energy. Okay, students, energy is needed to 1. Make stationary objects move. Look at this example. Okay, because of the energy acting on this car, so this object moves to the right side. Is it right? The second one, energy is needed to change the shape. That's right. And the third one is energy is needed to warm them up. For 30 degrees, when the object is warmed them up, it will be 90 degrees. Look at this one. The temperature is increasing from 30 degrees Celsius to 90 degrees Celsius. So we can say that energy is needed to warm the object. Is it clear, everyone? Okay, next. Talking about energy, we have to understand first types of energy. Many types of energy. There are many types of energy in this world. Thermal energy, radiant energy, chemical energy, nuclear energy, electrical energy, motion energy, sound energy, elastic energy, and gravitational energy. This is types of energy. So, energy measured in joule. All the energy dimension is measured in joule. Okay, students, we go to the next topic about this energy. Students, you're going to talk about kinetic energy. Look at this object. This car moves to the right side. As we know, this car has a mass, let's say m, and the velocity to the right side, let's say velocity is v. So the kinetic energy is formulated as E equals to a half m times v squared. And this energy measured in joule as well. We call this one kinetic energy. So the kinetic energy depends on velocity and mass. Okay, students? Okay, next, we go to the next type of energy. Potential energy. So what is potential energy? Look at this slow motion. This ball is going down from up to down. So it means the motion is downward. As we know, this motion depends on height and gravity of this object. Let the gravity of this object is g, and the height is h, and as well this object has mass, let's say we call that m. So these three properties will form potential energy. They are m, h, and g. This potential energy is working on y-axis or vertical axis. So potential energy is formulated as m times g times h, or E equals to m times g times h, and measure in joule. Is it clear, everyone? Okay, so what is work? Work is defined as a force causing the movement or displacement of an object. Once again, work is defined as a force causing the movement or displacement of an object. When work and displacement in 90 degrees, we call that no work. Work causes the movement or displacement. It means for the x-axis. We have to calculate all the measurement in x-axis. Look at this object. For this car acting F as a force. So this car is moving to the right side for displacement D. Work done. Work is done whenever a force moves something. We can find work done for this object by using formula work equal to F times D, when F is force and D is displacement to the x-axis. Okay, go to the next example. This object is moving to the right side, but F is acting on this object by theta. And displacement is D. Let's say the displacement is D. When I mentioned before that this force is acting for this object by theta. So we can write work done for this object by formula Fx to this object. As we know, when we found theta for this object f, we have to do the projection to fx and fy, right? We got the projection fx and fy respect to theta. Work causes the object moves. Force causing the object move by displacement d to the right side, or fx. So we can formulate it, this formula for this case, by w equals to fx times d. Fx is the projection to the x-axis. We can extend fx as f cosine theta. So work is formulated as f cosine theta times displacement. This is work measured in joule as well. Thank you, students. See you for the next topic. Bye-bye.